幸咧，想邀請我哋第一位嘅講者，咁係嚟自香港城市大學機械工程學系嘅郭少瑜先生。咁佢今日講嘅 topic 咧就係 Hydrogen Unmanned Aerial Vehicles。咁而家有請郭先生啊，咁交俾你啦，跟住我哋時間嚇。
Thank you, host, for your kind introduction, and thank you to the Hong Kong FCHEA for your kind invitation. And I shall now share my screen if that is okay. Okay, hopefully you'll be able to see my slides right now. Well, as I said, thank you to Hong Kong FCHEA for your invitation. I had a lot of constructive discussions on the offline session a few months ago, and now I'm again happy and to present some of our work on hydrogen-powered UAV in this online session. My name is Xiaoyu. I'm an incoming assistant professor with the Department of Mechanical Engineering, City University of Hong Kong. And today I will talk about some of our work on the integration, control, and applications of hydrogen-powered UAVs. Well, once again, I would like to begin with a brief introduction of the background. More specifically, our motivations for zero carbon autonomous flight. Well, recently we are all familiar with the keywords low altitude economy, as well as zero carbon and climate neutral aviation. It can be in the form of the flying cars we see in the news, and also UAVs for railway inspection, building inspection, etc. So while we are moving towards sustainable aerial vehicles, a key challenge is how do we achieve long-endurance, autonomous, and safe flight? So if we look through the history of aerial vehicles, we need to focus on the energy system, which is the heart of aerial vehicles. Well, more traditionally, aerial vehicles have relied on internal combustion engines or aircraft engines as its energy source. As its energy source. Well, more recently, most of the aerial vehicles we see today, such as the DJI drones, the most popular UAV, are mostly powered with lithium-ion batteries, which are the same batteries as we use in our phones, etc. And one benefit to that is that it brings sustainable, meaning zero carbon energy into aerial vehicles. And also, as most of our sensors and controllers are electrified, it's also convenient as it saves one procedure of energy conversion. So, however, as we all know, the battery-powered aerial vehicles has a key bottleneck in terms of endurance, meaning that most of these battery-powered aerial vehicles has an endurance of below 1 hour. Actually, most of them have an endurance of 20 to 30 minutes. So as we move from the aerial vehicle energy from traditional to sustainable, we reach our solution that is hydrogen-powered aircraft, aircraft powered by a hybrid between a hydrogen fuel cell and a lithium-ion battery that can achieve zero carbon emission while achieving much longer endurance, up to 10 hours, and also remain zero carbon and pollution-free. And again, a brief history on hydrogen-powered aircraft. So a little over 2 decades ago, AeroVironment company from the US developed the first hydrogen UAV, but it was more of a experimental prototype with an endurance of 15 minutes. Well, 10 years later, Liaoning Aviation Institute built China's first hydrogen UAV. And then 10 years after that, well, our team in CityU developed the first hydrogen drone that is capable of fully autonomous flight. Well, more recently, companies such as Joby from the US and H2Flight from Germany have developed larger hydrogen-powered aerial vehicles that are capable of manned flight. To give a brief introduction of the topology of hydrogen aircrafts, well, firstly, as it is a electrified aircraft, you have your aircraft motor and rotor system. And for the energy, as I mentioned before, you have a hybrid between a hydrogen fuel cell and a lithium-ion battery. Well, the reason we have this hybrid is that, as a lot of our colleagues might know, that while hydrogen fuel cells can have a quite high energy density, it has a relatively low instantaneous energy response. And in order to fix that issue, we hybrid it with a lithium-ion battery, which has a much higher specific power density that can produce the burst of power we need when we are doing highly dynamic maneuvers, such as takeoff and landing. Well, perhaps more uniquely to hydrogen aircrafts is the flight and energy controller unit. Well, whereas with traditional UAVs, you have a flight controller, typically a Pixhawk, a PX4, and a autopilot, meaning your inertia measurement units, GPS, etc. But with the hydrogen aircraft, we also need a specific dedicated controller for the fuel cell, which handles the controlling of all the BOP, or the balance of plant, within the fuel cell, and also handles power allocation between the fuel cell and the lithium-ion battery. And therefore, control and management is one of the unique challenges brought by hydrogen-powered UAVs, and also the core of autonomous flight. And now I shall move on to introduction of some of our work in academia on the safety control of hydrogen UAVs. Oh, in order for some of the audience to better understand this problem, I would like to draw some parallels between EVs and hydrogen-powered aircrafts. Well, the autonomous driving of EVs have also become somewhat of a hotspot in recent years. And also, this is also the motivation of why we want to develop autonomous aerial vehicles, because we want to bring the procedures such as building inspection and surveillance, etc. We want to bring automation into these procedures. Well, whereas if we see the environments between EVs and our hydrogen UAVs, you can see that some of the challenges we face are even more difficult to tackle. Firstly, as EVs are mostly driven on labeled environments, meaning you have fixed lanes, fixed road, and fixed traffic lights. Well, aircrafts, we move in unstructured environments. And it is also three-dimensional rather than two-dimensional. And also, whereas most of the EVs, such as your Teslas, your BYDs, are purely electric, it is solely battery powered, while our aircraft is powered by a hydrogen and electric hybrid, meaning that not only do we need to control the hydrogen fuel cell, we also need to handle the power allocation between the hydrogen and the electric battery in real time. And also, our aircrafts, as we all know, is propeller driven. It could be either 4 or 6 or 8 propellers. Well, whatever the number is, we need to handle the active power distribution between the propellers as well. However, the autonomous control and safe control of hydrogen aircrafts is still somewhat similar to EVs in terms of the challenges, meaning that we also focus on autonomy, safety, and efficiency. So how do we achieve this autonomous control of hydrogen aircrafts? Well, it all comes down to coordination between energy, meaning our hydrogen energy, and motion, meaning the propellers and the flight controllers of the UAV. And that involves embodied synergy between motion and energy via an integrated controller, and I will give some details on this controller unit later on. But also, from the algorithm side, it means that we need to integrate all of these flight and energy management algorithms, namely the trajectory planning, the flight control, the fuel cell control, the power allocation, the energy management, and the battery management. And we need to integrate those in a organic, in a safe and efficient manner. Well, in terms of research, of course, it comes down to a lot of interdisciplinary work. But as I all know, today is more or less towards a broader general audience. So I will not go into too much details on the specific research, but instead I will show some of our work on this topic. Well, before that, so to give a little bit of a background on autonomous flight. So two of the most important algorithms for the autonomous flight of hydrogen UAVs is trajectory planning, which refers to trajectory generation according to our mission and constraints, meaning that we have our time constraints, we have our space constraints, and we have our obstacles. And then we generate a trajectory uh, that fulfills all of our constraints. And the other one is power allocation. And this one is unique to our hydrogen hybrid UAV only. And that means that we need to create synergy between the fuel cell, which has higher density and slower response, and the battery, which has a lower capacity while a fast response. And this is also done in real time via the DC-DC converter. Well, so both of these algorithms also have shared objectives. We both want to enhance the energy efficiency, namely the efficiency of the fuel cell, and also the lifetime of the battery and the fuel cell. So with that theme in mind, we have done some work on the coordinated control and management of hydrogen fuel cells, and that allows us to increase the range by over 10% and prolong system lifetime by over 20% without modifying the hardware of our hydrogen UAVs. And secondly, we have conducted some work on autonomous safe planning and control, meaning that we have integrated trajectory planning, energy management, and UAV and fuel cell control to enable autonomous planning, control, collision avoidance, landing, and takeoff, meaning that all the flight you see on this video, it is fully automated. And thirdly, as we are in terms of UAVs, we are particularly focused on safety, and that is even more important when we consider the safety of hydrogen fuel cells. And that's why we developed these safety controllers that can improve flight control accuracy and also allows us to land safely even with a broken propeller or under strong winds. Well, as I mentioned before, so the coordination between the flight and energy domain is not only, it does not only mean the combination of two algorithms. In terms of the hardware controller architecture, we also co-optimized the flight controller and the energy controller with this co-domain integrated computer on board our UAV. And this enables a wide range of autonomous applications such as path planning, monitoring and inspection, as well as fire rescue. And then finally, a little bit of prospects on the research side. So recently, some of you might be familiar with the word embodied energy. This is a word that is used as a parallel to embodied intelligence. That is also quite popular with the AI realm. And that means, well, if you think about it, like us as humans, or this flying rat that we see in this slide, they do not store all of their energy within an external battery or a fuel cell. Instead, we store our energy in the fat in our body and in various organs. And what embodied energy means is that our lab, we're also trying to move beyond the traditional paradigm of UAVs, meaning that we design our propellers, our flight controllers, etc., and then we slap a fuel cell or a battery on top of it. But instead, we are trying to integrate the power generation, the hydrogen production, and the hydrogen storage within these structures and materials of these UAVs. For instance, take this flying rat as an example. Actually, we can use flexible fuel cells, these new materials as the wings for this UAV. And we can store hydrogen within this solid hydrogen storage, within these metal powders that can be stored within the structure of the UAV itself. And I believe this will be perhaps a very important future direction of aerial vehicle design, and that is an integration between material, mechanism, and control. Well, again, I'll not go into too much details on the research side, but if you're interested, you can always refer to some of our select publications. And also this year, we have published one of the first monograph on safe control of hydrogen fuel cells theory and practice with Springer Press. And also this year, back in the mainland, we have formed the first team standard on the general technical requirements for hydrogen energy unmanned vehicle, where we have also outlined some of the safety standards for the hydrogen UAVs. And now moving on to something that might be more interesting for the general audience and some of you that are working in industry, and that is the applications and some of the prospects, some of the impact cases of our self-developed hydrogen UAV. First, to answer the very important question, so how large is our hydrogen UAV? Well, the answer is it depends. So the smallest ones that we have developed is 25 kilograms in weight, and it utilizes a 3 kilowatts fuel cell pack and also has a maximum payload of 6 kilograms, and it can achieve a endurance fully loaded of almost 3 hours, which is quite impressive, especially compared to the battery-powered counterparts. But also utilizing this platform that we call the modular energy platform, we can cover a wide range of weight classes. For instance, by combining 4 3 kilowatts fuel cells to form a multi-fuel cell system, we can develop this 100 kilogram UAV with a maximum payload of 40 kilograms. And by forming a fuel cell matrix, meaning 4 by 4 3 kilowatts fuel cells, we have this recently developed. We developed this quite large 360 kilogram UAV with a maximum payload of over 100 kilograms. And I would like to note that even with 100 kilogram of payload, it can still achieve an endurance of over 1 hour. And also, this modular energy platform allows for extra safety and endurance, meaning that within this 4 by 4 structure, even if some of the fuel cells they break down or they're in faulty conditions, the UAV can still fly and land safely. And now move on to some of the typical applications. Well, all of the videos we've seen here, these are real application and experimentations on our hydrogen UAVs. So the 3 key application can be summarized as first, logistics, meaning energy emergency delivery and delivery of search and rescue equipment or on-site sampling. And one benefit of hydrogen power to this logistics application is that it has a rather large payload. For instance, the 360 kilogram UAV we shown in the last slide, it has a payload of 100 kilograms, which allows us to carry quite significantly larger payloads and still fly for over 1 hour. And the second is surveillance, meaning autonomous inspection, such as the building inspection here in Hong Kong, and also urban or traffic surveillance, and also, well, surveillance of our ecosystem in Hong Kong, such as our forest and our coastlines. And this is related to the long endurance of our hydrogen UAV. So typically, if we want to inspect a building, well, I have talked to some of the engineers here in Hong Kong. So the traditional solution is we have a UAV, but we also have like 5 or 10 batteries ready to go on the ground. So what they do is, for a skyscraper, for instance, they surveil the first couple of floors, and then the UAV comes down, we replace the lithium-ion battery, then it goes back up again, and then repeats this process 3 or 4 times with inspection. But with our hydrogen UAV, because it has a longer endurance of over 3 hours, we do not have to repeat the battery placing process. And instead, the building inspection and the urban surveillance can be completed all in one go. And thirdly, perhaps a more novel application is computing and communication. So we have also collaborated with some our industry partners, such as China Mobile, to bring some of the 5G communication modules and also these edge computing modules on board our hydrogen UAV. So why is this important? Is because it breaks the typical paradigm of UAVs being only a carrier of, let's say, equipment or cameras. So it moves beyond logistics and surveillance, meaning that this time UAVs can be a provider of computing power. It can be a provider of communication power, such as in a search and rescue case. Actually, by carrying a 5G communication module, we can provide internet for perhaps a 1 to 2 kilometer radius below our UAV. And that is quite important for a lot of the urban applications as well, such as aerial networking and distributed perception, as well as mobile edge computing. Well, over the years, we have applied our UAV with a lot of industry partners, and also build, as I mentioned before, the team standard for the general technical requirements for hydrogen UAV systems. And now moving on to some of the perhaps more interesting impact cases of our UAV. So this is also an ongoing project that we are developing our hydrogen UAV for Antarctic exploration and operation. So it is a common theme internationally that is with Antarctic environments, we are trying to use more unmanned systems, such as UAVs, such as these robots, you call it robot dogs, for exploration, because it is simply more durable and frankly safer than using humans. And that is, however, as we all know, batteries, they don't perform well in low temperature. And that is why hydrogen fuel cells is a great candidate for Antarctic flights. So firstly, fuel cells naturally carries a larger amount of energy. And secondly, as many of you all know, that hydrogen fuel cell generates a lot of heat while it generates power. So while in typical urban environments, such as Hong Kong on a hot summer day, this heat is perhaps blown out, they're dissipated by the fans. But in Antarctica, this heat can be a valuable resource to warm up and to maintain the optimal temperature for our fuel cell. And that is what we developed in our Antarctic hydrogen UAV, is that we developed a heat recycling and reuse mechanism in order to enable startup and safe flight within below 25 Celsius degrees. And this is an example of our embodied energy design based on electrical and thermal coupled energy flow. And this is also an ongoing collaboration with the Polar Research Institute of China. So this UAV will be on its way to the Antarctica next month. And secondly, as I mentioned before, we're trying to break the paradigm of UAVs only as a carrier. We're trying to bring the functions of computation and communication to our hydrogen UAVs. Why is this something that only hydrogen can do? Because as we all know, edge computing devices and these communication modules, they are very they consume a lot of power. So with typical lithium-ion battery UAVs, the UAV itself, even with zero load, it can only fly for half an hour at a time. So carrying all these extra loads, and while these loads are also consuming power, so typically they cannot fly for maybe over 5 minutes. But with hydrogen fuel cells, this platform that shown here, it can fly for over half an hour at a time while carrying a computing device and a communication module. So this enables a lot of novel applications such as local LLM implementation on air, and it can do low altitude networking within all our Internet of Things agent on the ground. So truly making it a low altitude communication, perception, and computing agent. And this is also an ongoing project with the China Mobile Group Design Institute. To conclude, well, I believe that hydrogen is a great solution for long endurance and sustainable aviation. And in terms of electrified sustainable aviation, it is perhaps the only solution at this point. And also, our team, we have developed a series of not only hydrogen UAVs, but we refer to intelligent aerial robotics with applications in polar, aerospace, and also edge computing. And finally, a few words on our industry partner, Suzhou CX Tech. Well, I have a lot of great conversations with industry partners on our offline session in June. So our partner CX Tech, where I'm also a co-founder, we not only focus on hydrogen-powered UAVs, eVTOLs for low altitude applications, we also provide a number of hydrogen mopeds. We have sold over 1,000 mopeds back in the mainland in Suzhou and Beijing and Lianyungang, Jiangsu, China this year alone. And we also provide training aids and these research test bench on hydrogen, and also the full loop solutions for hydrogen energy storage and hydrogen production, as well as power generation via hydrogen fuel cells. Well, finally, I would like to thank you all for your attention. Of course, you're all welcome to contact me via email, or you can add my WeChat from the QR code above. Thank you.